Hello, Nanostomes. Before we get to the stupid, I would like to give a big thank you to InFixFun, who has been a very awesome person and put closed captions on all my videos. Thanks! So, what to debunk? What to debunk? Hey Google, find me something really stupid.
Okay, here is what I found. If you belong to this blood group, chances are you could be having alien DNA.
Yep, that'll do. So, the following, which I have to stress is real and presented verbatim, is from a bottomless pit of listicles and clickbait called Throw-Up. Or Throw-Up. Throw-Up? Thrope. Throw-Up? Yeah, let's go with that one. This particular article was vomited up by Andrew Alpine, who appears to be a frequent contributor to the site. Oh, and if you're wondering how I found this stupid, it was suggested to me by the Google Plus trending feature. And if you use one of Google's other products and search for alien blood type, you'll get a shitload of results. So yeah, apparently people actually believe this. Okay Google, read the stupid for us.
The biggest answered question of human physiology is if humans are descended from monkeys. Why some humans don't have the rhesus monkey gene.
Oh dear fuck. 0 to dumber than a wet cardboard box in 3.4 seconds. First of all, that would be a question for human evolution and genetics, not physiology. It's not the biggest question in any of them, and I think you meant unanswered. Secondly, that's not how evolution works. Humans didn't evolve from rhesus monkeys, or rhesus macaques to give them their proper name. You share a common ancestor with them. Now, most people with rhesus negative blood are in fact missing the rhesus monkey gene, or RHD, to give it its proper name. But so are all the rhesus macaques, because the gene didn't evolve until after the two lineages split. It's not named rhesus because of anything to do with evolution. It's named that because that's the animal the Rh blood group system was originally discovered in, back in the late 1930s. Well, sort of. It quickly turned out that what was discovered in the macaques was actually a different blood group system than its human equivalent. But by that time, the name was already in wide use, so it stuck. But you know what? Let's forget all that and say the system really is named after the rhesus macaque because humans evolved from it. How does that make humans not having it an evolutionary mystery? No, seriously, how? How is a species evolving an evolutionary puzzle? You do realize that there are a lot of genetic differences between humans and macaques, right? That's why you and them are different species. Guess how they ended up that way? That's right. Fucking evolution.
Darwin laid forth the theory of evolution, no doubt, but this question remains unanswered.
Jesus Christ on a blue mountain bike. It's not unanswered. Humans evolved. It's right there in the question. You're literally asking why, if species evolve, don't they stay the same?
A new theory is proposing that those with Rh negative blood could be having alien DNA.
It's not a theory. It's not even a hypothesis. It's somewhere around the badly thought out shower thought of someone who hasn't had their morning coffee yet. Also, only the R in RH is supposed to be capitalized. Wait. By alien DNA, you mean space aliens, right? And not aliens as in Mexicans.
The alien DNA blood type is being regarded as such because those with Rh negative blood do not possess the rhesus monkey gene found common to all humans.
Again, yes, most Rh negative people have that blood type because they lack the RHD gene. Don't worry, I'll get back to the how and why of that. For now, I really want to know how the hell you got from that to alien DNA. Never mind how that's a complete non sequitur. How the actual chocolate-coated fuck can missing a gene equal having alien DNA? They're missing the gene because they lack the part of the DNA where it's supposed to be. It's not pining for the fjords. It's not there. It's gone, vanished, deleted, no longer in existence, lost to time. It is an X gene.
There are 4 common blood types, A, B, O, and AB.
Within the ABO blood group system, yes, those are by far the most common types. There are others, but they're rare, and most are basically versions of either A or B, with some caveats. Thing is, there are also other blood group systems, 36 of them to be exact. The ABO system is just one of them. The reason you hear about it the most is because it's the one most likely to cause problems during blood transfusions and organ transplants, making it the most clinically important.
The protein characteristics are what creates the differentiation between the types.
I mean, that's not true, but it's also not much of an explanation. So, let me do it for you. Fair warning, this segment is gonna be a big info dump, so hold on to your pants. All of your cells have proteins on their surface that they use to communicate and interact with the rest of you, and sometimes things that aren't you. Some of them also act as antigens. Antigens are parts of molecules, usually proteins or complex sugars, that can be recognized by the immune system and cause it to respond. What antigens someone has and what they look like is determined by their genes. Because humans aren't clones, people have different antigens. Your immune system knows, for a lack of a better term, what your antigens look like, and has cellular safety mechanisms in place so it doesn't attack them. Autoimmune diseases are what happens when those mechanisms fail. Blood types have to do with the antigens on the surface of the cells in your blood, primarily those on the red blood cells. The protein characteristics Andrew is talking about are the structure of these antigens. Each of the 36 blood type systems deals with one or a group of related blood antigens. The types refer to what antigens and antibodies someone has. So, if someone is type A, that means they have the A version of the ABO antigen, but lack B, and likely has antibodies against it. In most cases, someone's type in the ABO system is determined by what versions, known as alleles, of the appropriately named ABO gene they have. A bit confusingly, it's not the protein coded for by ABO that's the antigen. In fact, that protein stays inside the cell. You see, a lot of surface and extracellular proteins are glycoproteins, meaning they have branching chains of different sugars glued onto them. The ABO antigen is one such sugar chain. The ABO protein's job is to help build this chain by putting a single sugar on a certain part of it. What sugar is put on determines the blood type. Acetyl-galactosamine gives you type A, while galactose results in type B. Type O means the ABO protein is either missing or broken, so nothing gets put on. Type AB just means you have both A and B. For most genes, you have 2 copies of it, one on each chromosome in a chromosome pair, so you can have 2 different alleles. On to the star of the video, the Rh blood type system. It involves 2 genes, RhD and RhCE, each code for one of 2 very similar surface proteins found only on red blood cells, and unlike in the ABO system, they are the antigens. There are 3 antigens, C, D and E. You can probably guess which one carries which. The Rh system is the largest of the human blood group systems, with over 50 different types. Most of them are rare, so we'll just stick with the 6 common ones: small c, d and e, and big C, D and E. The 2 C's and E's are different looking proteins, just like A and B, but the D's aren't. Small d is not an actual antigen, because it's not a protein, but rather the lack of RhD. It's Rh negative. When we talk about someone being Rh negative or positive, we're saying whether or not they have RhD. The reason we don't usually talk about RhCE is because it's less clinically relevant. The immune system is much more likely to have a strong reaction against a protein it's not used to than to a protein that just looks slightly different. That was a lot longer than I wanted it to be. Hopefully you got most of it.
But concerning Rh-negative blood types that make up approximately 15% of the population, such proteins are missing, which is leading scientists to ask the big question: where do such people with Rh-negative blood originate from?
Well, it led scientists to ask that question. They came from Africa. We actually have a pretty solid idea of where Rh-negative came from. More on that in a moment. I want to address a couple of smaller points. Firstly, the 15% of the population is only true for Europe and North America. In the rest of the world, Rh-negative is much rarer. Secondly, Andrew thinks the protein missing in Rh-negative people is the ABO protein. It might be hard to tell with me interrupting him, but if you read the whole paragraph, it very much seems like he does. The headline of this section also helped a lot. But, no, they're not the same. And RHD and RHCE aren't glycoproteins, so I can't even be nice and assume he meant they carry the APO antigen. Also, not every Rh-negative person has completely lost the D antigen. It's just the most common allele. To understand where Rh-negative came from, and spoilers, it wasn't aliens, we first need to understand how RHD came about. RHD and RHCE are members of a larger family of rhesus genes, a very old family, dating back to at least the common ancestor of all vertebrates. As I mentioned, rhesus macaques don't have the RHD gene, but they do have an equivalent of RHCE. I also mentioned that the two proteins are very similar. The genes for them share 92% of their coding parts. They're also right next to each other. What all of this suggests is that RHD came about as a result of RHCE being duplicated. It's also a clue to how it was lost again. Your cells are able to do something called homologous recombination. I won't get into the detail of how it works. All you need to know is that it's a way to swap similar looking parts of DNA. The cells mostly use this ability to repair damaged DNA. It's also used to mix up genes during meiosis, the type of cell division used to make egg and sperm cells. The process of homologous recombination isn't perfect. Sometimes things go wrong. That's how RHD got deleted. Because the two genes are so similar, the homologous recombination protein machinery confused two parts on either side of RHD and so ended up cutting it out. That's not just speculation. If you compare the DNA sequences, you can actually see where it was put back together.
According to scientists, such blood type could have existed in 35,000 years ago and linked to ancient tribes and groups.
Looking around the internet, this 35,000 years ago pops up a lot, usually accompanied by other words explaining how unnamed scientists think this is when humans got the blood type from either aliens or Neanderthals. I didn't bother to track down the source, because fuck that. It doesn't matter where it came from. What matters is that it's wrong. Now, to be fair, Andrew doesn't actually say that this is how old Rh-negative is. He just says it was around. Which, yes, it would have been, because it's hundreds of thousands years old. We know this thanks to genetics. While Rh-negative is rare in people from the African part of the world, as this failed attempt at journalism correctly goes on to say, there are still some who have it. Among them, and a larger percentage who are carriers of it, the most common reason is the exact same deletion mutation you find in the rest of the world. It's not nearly as common as in Europe, where it's responsible for 99% of Rh-negative peeps. It's more like 60%, but it's there, including in people who have no non-African ancestors. If you haven't already worked it out, that means the mutation must have happened before humans left for the rest of the world. That happened some 75,000 years ago. And since the allele is found throughout Africa, it must also have happened before anyone migrated out of East Africa 200 to 300,000 years ago. That's just a tad longer ago than 35,000 years. It's likely even older than that. The way the DNA around RHD and RHCE is set up is practically begging for a deletion via homologous recombination to happen. In fact, it's not at all unlikely that Rh negative was already a thing when Homo sapiens arrived on the evolutionary scene.
The blood type is prevalent among Europeans and just 3% of Africans have it. In Asia it may be found in 1% of the people.
In other words, it must have happened early in or before the evolution of modern humans. Thanks for agreeing with me for once. It's not entirely clear why it's so much more common in Europeans. I found a few different ideas, but from what I've read, the current consensus is that it's probably because of a combination of the founder effect and genetic drift, which is another way of saying that it's mostly due to random chance. The founder effect means that the people who left Africa and became the ancestors of Europeans just happened to come from a tribe or group where the RHD deletion was prevalent. Genetic drift happens because which genes are passed on to the next generation is random. In a small population, genes with little to no selection pressure on them can disappear or become much more prevalent due to this randomness.
Those possessing this blood type Rh negative have common characteristics such as high IQ, lower body temperature, heightened awareness, red hair, heat sensitivity, blue, green, or hazel-colored eyes.
No, you pulled that directly from someone's rectum. The only two that comes close to being real things are the hair and eye color. Rh negativity is much more common in blue-eyed redheads. That's not because RHD has anything to do with your colors. We have a pretty good idea of how that actually works. Rh negative and red hair just happen to be the most common in the same general population, those of European descent. You might as well be saying that sickle cell anemia makes you black.
The blood type is a bit of a mystery.
No, not really. The only major mystery is if the RHD protein actually does anything, and if so, what that thing is. Structurally, it looks like an ammonia transporter, and other proteins in the Rh family do perform that function in the kidneys. Whether RHD actually works is unclear. The current best guess is that it doesn't. It's part of a complex with RHCE and another Rh protein called RHAG. The complex likely acts as an ammonia transporter, with RHAG doing the actual transporting. RHD and RHCE are thought to be there for structural reasons.
Take for example Rh negative women who are pregnant. Their bodies face difficulties in delivering Rh positive babies and reject the fetus or even trying to kill it, which is why they are given a special sterilized solution.
That hasn't been much of a mystery since the 1940s. How do you think we figured out to use this special sterilized solution? What he's vaguely referring to is called Rh disease. It's a subtype of a condition called hemolytic disease of the fetus and newborn, or HDFN for short. Normally, maternal and fetal blood is separated. However, they can and do get mixed from time to time, especially during childbirth. In an Rh negative woman expecting an Rh positive child, that can be a problem. The mother's immune system will correctly identify fetal red blood cells as not being hers and start producing anti-RHD antibodies. Those antibodies are able to cross the placenta and will start destroying the fetus's red blood cells. If the reaction is strong enough, that can lead to anemia and in severe cases kill the fetus. And since the mother has effectively become vaccinated against RHD, any future Rh positive unborn children will be at risk too. Not only that, but the severity tends to increase with each Rh positive pregnancy. Since sick and stillborn babies have consistently placed low on Throw-Up's 10 Things We Want lists, medical professionals got together and came up with a preventative treatment. That's the special sterilized solution Andrew mentioned. Bit weird that he felt it was more important to mention that it's sterile than to explain what's in it, or mention that it's an injection. What's in the special solution is anti-RHD antibodies, the same antibodies responsible for the problem. Sounds counterintuitive, but it's actually pretty clever. The dose is low enough that it won't harm the fetus, but it's high enough that if any of its red blood cells ends up in its mother's blood, they'll be swiftly eliminated, hopefully before her immune system has a chance to notice them and respond. No immune response, no problem. Oh shit, it's supposed to be a mystery. I'm so sorry guys, forget what I said. No one has any idea how any of it works. They just randomly injected things until they found something that worked. So shh, it's a secret. Shh, no one knows.
But the weird thing about such a condition is, why would a woman's body reject its own fetus?
I don't know. Why would someone's immune system start attacking their pancreatic beta cells and give them type 1 diabetes? That's super weird and mysterious. Oh wait, I do know. It's because the human body, including the human immune system, isn't perfect, but faulty as a result of being the product of a mindless and aimless process, which improves on previous iterations through incremental changes to them. You know, evolution. One of the underlying arguments of this whole article seems to be a weird reverse version of the old creationist favorite of irreducible complexity, that it can't be evolution because it's not perfect. Wait, have we actually found someone who fits the creationist idea of what an evolutionist is? Is this what creationists think we think? Is this how they see us? No wonder they think we're stupid.
This is why the relatively new theory that is suggestive of the possibility of alien DNA influencing such a blood type.
That was almost a whole sentence. I think it's trying to say that Rh disease is evidence for the stupid, because isn't it weird how a pregnant woman's immune system would attack the fetus? Must be her alien DNA not matching with the human fetus. Not only is that functionally equivalent to going, I don't get it, must be aliens, it also raises the question of what Andrew thinks about the other blood types. Since HDFN can be caused by maternal antibodies against other antigens than just RHD, by Andrew's logic they must be alien too. I don't think that was what he was going for, but that's where his argument leads. Which raises the further question of what the hell the aliens' deal with blood is.
It gets weirder concerning those having this alien DNA blood type.
I seriously doubt this can get weirder, but go on.
In all cases of alleged alien abductions, all the victims were Rh negative.
Well, color me whatever color, acting as if this is the first time I'm hearing this, and I'm surprised by it for entertainment purposes, it did get weirder. And dumber. No, all alien abductees are not Rh negative. Primarily because alien abductions aren't real.
Such H observations are highly indicative of the possibility that our planet was indeed visited by aliens who somehow influenced the genetic composition of man, leaving their own mark on some of them.
No, it's highly indicative of the possibility that you didn't do terribly well in science class, or in writing class. Seriously, did you write this by dictating it to a dyslexic arkwart?
Throughout time, history and archaeology from all over the world has yielded hints and signs that aliens visited our planet.
And naturally, that must mean these aliens fucked around with some of our ancestors' DNA in a way that perfectly resembles a mutation that would like to have happened anyways. After all, that is the next logical step.
From the pyramids, to Mayan ruins, scriptures, ancient texts, figurines, cave drawings and temples, man has always been given subtle hints that ancient Earth was home to possible civilizations not of this world, or were indeed visited by beings from beyond.
So I'm not going to go into why ancient aliens is more retarded than a sea slug on glue. That would be a whole video in itself. What I am going to say is that all the evidence I have ever seen have either been fakes or misinterpretations. Also, most of the things you listed are completely irrelevant to this, since they happened way after the deletion mutation you think was alien genetic engineering. Wait, you do think it was genetic engineering, right? Right? Please tell me you're not so stupid that you think they did it by doing it like they do on Discovery Channel. Or I guess in this case it would be the History Channel.
Only further investigation, discoveries and research will provide an answer whether this alien DNA blood type is the missing link in evolution. It could well mean that some humans have alien DNA.
No, we don't need to spend time and money looking into an idea that is not only implausible to begin with, but also goes against what we already know. And we certainly don't need further investigation to figure out if missing a section of DNA means you have DNA from aliens, because that sentence still doesn't make any goddamn sense. Stick to more obvious topics, like how it turns out petting a wild lion is a crap idea, and leave the science alone.